3I-Atlas hasn't even reached its closest point to Earth yet. But fake videos about it already fooled millions of people. One channel was using AI to impersonate a Harvard astrophysicist. They cloned his face and voice. Posted videos claiming 3I-Atlas was alien technology. Racked up over 1 million views in 2 weeks. The fake videos were so convincing that even a news outlet used the footage in their reporting. YouTube eventually removed the channel, but only after people started noticing details. Like the clock frozen in the background. Or the missing facial scar that the real professor has. If you've been watching 3I-Atlas videos, you've probably seen conflicting information. Alien spacecraft. Collision course. Deadly gases. Some of it sounds convincing. So before you believe the next one, we're fact-checking the 4 biggest claims. With actual sources. NASA data. ESA observations. Information you can verify yourself. Claim 1. It's an alien spacecraft. This is the big one. Videos calling it an alien probe. Saying the gas jets are actually engines. Claiming it's making controlled thrust maneuvers. Here's what we actually know. In August 2025, the James Webb Space Telescope pointed its near-infrared spectrograph at 3I-Atlas. Webb can see the chemical fingerprint of gases. And what it found was carbon dioxide. A lot of carbon dioxide. The ratio of CO2 to water in the coma around 3I-Atlas is about 8:1. That's unusually high for a comet. But it's still just carbon dioxide and water. Webb also detected carbon monoxide, carbonyl sulfide, and water ice. These aren't mystery substances. They're the same volatiles you find in comets from our own solar system. The production rates were measured. Carbon dioxide coming off at 129 kilograms per second. Water at 6.6 kilograms per second. Carbon monoxide at 14 kilograms per second. The Hubble Space Telescope estimated the size of 3I-Atlas. The nucleus is somewhere between 320 meters and 5.6 kilometers across. Probably closer to the small end of that range. For comparison, the Death Star in Star Wars is 160 kilometers wide. 3I-Atlas is at most a few kilometers. That's small. And Hubble captured images showing a dust plume on the side facing the sun. That plume is exactly what you'd expect from a comet heating up. The Very Large Telescope in Chile detected cyanide emission. About 17.6 grams per second. They also found atomic nickel at 4.6 grams per second. Before anyone panics about nickel in space, this is normal. Other comets emit nickel. It comes from the breakdown of organic compounds when the comet heats up. The concentrations match what we see in solar system comets at similar distances from the sun. So where are the jets everyone's talking about? They're there. But they're not engines. When a comet gets close to the sun, frozen gases on the surface turn directly into gas. That's called sublimation. The gas escapes through cracks and vents in the surface. It carries dust with it. That creates jets. They point in different directions because the comet is rotating and the surface is uneven. Some parts face the sun and heat up faster. Other parts stay in shadow longer. You can actually see this pattern in the data. The Very Large Telescope observations showed the gas emission was stronger on the sunward side of the comet. That's exactly what you'd expect from solar heating. If these were engines, you'd see thrust in specific directions to change the orbit. You'd see symmetrical patterns. You'd see consistency. Instead, you see chaotic outgassing driven by which parts of the surface are currently facing the sun. This is what every comet does. You can watch videos of Comet 67P from the Rosetta mission. Jets everywhere. Dust streaming off the surface. And that comet was absolutely, definitely not an alien craft. We had a spacecraft orbiting it for 2 years and a lander sitting on its surface. The difference with 3I-Atlas is the chemistry. That unusually high carbon dioxide ratio tells us something interesting. It probably formed farther from its parent star than most comets in our system. What's called the CO2 frost line, where temperatures are cold enough for carbon dioxide to freeze solid. That's actually more evidence it formed naturally around a different star. Not less. If this were a spacecraft, you'd expect to see things that don't match natural processes. Unusual materials. Geometric structures. Controlled deceleration. Radio emissions. Heat signatures that don't correlate with distance from the sun. We're not seeing any of that. What we're seeing is ice turning into gas. That's it. The alien spacecraft theory falls apart when you look at the actual data. It's a comet with interesting interstellar chemistry, which is way more scientifically valuable than another comet from the Kuiper belt. But it's not a probe. If 3I-Atlas were actually alien technology, we'd see specific signatures. Materials that don't occur naturally. Geometric structures in high-resolution images. A trajectory that doesn't match gravitational physics. Radio emissions that look artificial. Heat management systems that don't correlate with solar radiation. Controlled deceleration as it approached the sun. We're seeing none of that. What we're seeing is frozen volatiles sublimating when heated. That's it. Claim 2, it's releasing deadly chemicals. Videos claim 3I-Atlas is emitting unknown toxic gases. That it could poison Earth's atmosphere. That these are chemicals we've never seen before. Let's go through what's actually being detected. The James Clerk Maxwell Telescope in Hawaii used radio observations to detect hydrogen cyanide. The production rate was between 1.5 and 4.5 times 10 to the 25th molecules per second. That sounds like a lot. It works out to about a quarter to half a kilogram per second. And yes, hydrogen cyanide is toxic. But here's the thing. Every comet produces hydrogen cyanide. It's one of the most common molecules in cometary comas. In fact, that distinctive smell of bitter almonds that people associate with cyanide? You'd never smell it in space. There's no air to carry it. And the concentration is so low that even if you were right next to the comet, you wouldn't be in danger. The ratio of HCN to water in 3I-Atlas is about 0.2%. That's well within the normal range for solar system comets, which goes from 0.03 to 0.4%. There's nothing unusual here. Comets are full of organic chemistry. Hydrogen cyanide is a building block for more complex organic molecules. It's actually part of the prebiotic chemistry that might have helped life start on Earth billions of years ago. Scientists study it because it's interesting, not because it's dangerous. ALMA, the big radio telescope array in Chile, detected methanol. About 40 kilograms per second. That's higher than typical. But methanol is also common in comets. It forms when ultraviolet light hits water ice mixed with carbon-rich materials. And again, we're talking about gas dispersing into the vacuum of space. It's not concentrated. It's not a cloud heading toward Earth. Here's what people need to understand about space. It's empty. Really, really empty. When 3I-Atlas releases these gases, they spread out over millions of kilometers. The coma around the comet is about 15 kilometers across where you can see it. But the actual gas extends much farther. And the density is absurdly low. You could fly through the coma in a spacecraft and barely notice. The molecules are so spread out that calling it a cloud is misleading. It's more like a very faint mist spread across a volume the size of a small planet. Now let's talk about distance. On December 19, 2025, 3I-Atlas will make its closest approach to Earth. It'll be 1.8 astronomical units away. That's 270 million kilometers. For reference, the Sun is 150 million kilometers from Earth. So 3I-Atlas will be nearly twice as far away as the Sun. Mars at its closest gets to about 55 million kilometers from Earth. This comet will be 5 times farther away than Mars ever gets. The comet passed its closest point to the Sun on October 29. It was $1.36 from the Sun, which is between the orbits of Earth and Mars. And at that time, Earth was on the opposite side of the Sun. We were nowhere near it. Now the comet is heading back out into deep space. It's already moving away from the Sun. And it'll keep moving away forever. There is zero chance any gas from 3I-Atlas reaches Earth's atmosphere. The concentration would be so low by the time it traveled 270 million kilometers that it wouldn't be measurable. You'd need to collect millions of cubic kilometers of space to get a single breath. And the comet isn't heading toward us anyway. It's heading away. Even if every molecule of hydrogen cyanide the comet released somehow magically traveled straight to Earth, it would be diluted across the entire volume of space between here and there. By the time it arrived, the concentration would be less than what's already naturally present in Earth's upper atmosphere from other sources. The chemicals aren't unknown. They aren't unusual for a comet. And the comet never gets anywhere close to us. This claim is completely false. Claim 3, it's on a collision course with Earth. Some videos are saying 3I-Atlas is heading straight for Earth. That debris will rain down on us. That we're in danger. This is probably the easiest one to debunk because the numbers are very clear. NASA's Jet Propulsion Laboratory has been tracking 3I-Atlas since it was discovered in July. JPL maintains a database of every object in the solar system we know about. They calculate orbits. And 3I-Atlas has an orbital eccentricity of 6.14. If you don't know what eccentricity means, here's the simple version. A circular orbit has an eccentricity of 0. Earth's orbit around the Sun has an eccentricity of 0.017. It's almost circular. An elliptical orbit has an eccentricity between 0 and 1. Halley's Comet, which loops around the Sun and comes back every 76 years, has an eccentricity of 0.967. Still less than 1. When the eccentricity is greater than 1, you have a hyperbolic orbit. That means the object isn't bound to the Sun. It's moving too fast. It came in from interstellar space, it's swinging around the Sun once, and it's leaving forever. 3I-Atlas has an eccentricity of 6.14. It's extremely hyperbolic. There is no version of physics where this object stays in our solar system. To put that in perspective, you need to be moving faster than about 42 km per second to escape the Sun's gravity from Earth's distance. 3I-Atlas is moving at 58 km per second relative to the Sun at infinity. It has way more than enough speed to escape. The comet reached perihelion on October 29. That's the closest point to the Sun in its orbit. It was $1.36 from the Sun. About 203 million kilometers. Between Earth and Mars. And it's already past that point. Right now, it's moving away from the Sun. Its speed is decreasing as the Sun's gravity pulls on it, but it's still moving at tens of kilometers per second. Way faster than escape velocity. The closest 3I-Atlas will come to Earth is December 19. It'll be $1.80 away. That's 270 million kilometers. To put that in perspective, the International Space Station orbits 400 kilometers above Earth. The Moon is 384,000 kilometers away. This comet will be 270 million kilometers away. It is not close. And it's not coming back. When an object has a hyperbolic orbit, it means it came from outside the solar system and it's leaving the solar system. The Sun's gravity bent its path, but not enough to capture it. And if you want actual space news without the clickbait, subscribe. Because 3I-Atlas is leaving.